In this video, we're discussing the laws of exponents, and we're going to use those laws to simplify the expressions here below. I've written the order of operations in the upper right-hand corner, not because I think you've forgotten the order of operations, but rather because I want to show a connection between the order of operations and these laws of exponents. Let's think back to what happens when you multiply two terms with the same base. So, for example, if I multiply x to the third times x squared, what happens in that situation? Well, the rule says we keep the common base and we add the exponents. So it'll become x to the fifth. So if you look at what happens then in terms of order of operations, when multiplying these common bases, we add the exponents, right? So maybe when we divide the common bases, we subtract the exponents. Is that true? It turns out it is. So if I do x to the third divided by x squared, I keep the common base of x, and I subtract these two exponents, so I'll have 3 minus 2 in the exponent position, or just x to the first power. The only other option that we need to worry about is what happens when you raise a term to a power. Well, then we'd multiply the exponents. So if I raise, something like x to the second power to the third power, then the rule says I keep the base, and I simply multiply these two exponents to give me, for example, x to the sixth power in this case. All right, so that's basically the connection. The connection is whatever you do to the base, you do one order of operation lower to the exponents. So when multiplying common bases, add the exponents. When dividing, subtract. And when raising something like x squared to a power, you multiply the exponents. All right. With that in mind, let's go ahead and simplify these terms over here on the left. All right, so let's evaluate this first expression. First thing I want you to notice is that 7 is not just 7, it's actually 7 to the first power, right? Because 7 to the first power is 7. So I'm going to go ahead and put a little exponent here of 1. Now, with that in mind, what I'm going to do is take this exponent of 2 that's out here, outside the parenthesis, I'm going to distribute it in. So I'm going to call that 7 squared now, because 1 times 2 is 2. And remember, when raising the term to a power, we multiply the exponents. So now it'll be 2 times 4 here to give us x to the 8th power. And then with that, I can simply say that 7 squared is 49. And then I'll have x to the 8th. And that is the solution to this one. Okay, so that's fully simplified. Let's look at problem B. Same idea here. We're going to take this exponent and distribute it in. So I'll have x to the negative 6th power, because 3 times negative 2 is negative 6. And then I'll have 3 times 2 here to give us y to the 6th power. All right, so we would be done here at this point, except for the fact that we do not like to have negative exponents. So what we can do is we can make this into a fraction by putting it over a denominator of 1. And then we can remember this little rule, and the rule says this. It says if you cross the line, so cross the line, you're going to change the sign. And what we mean by that is change the sign of the exponent. So if we bring this term down, it'll end up being x to the 6th on the bottom and y to the 6th on top. So what I did is I moved the x to the negative 6 down below, and what happens when it crosses that fraction bar is it ends up having a positive exponent. The y to the 6th can stay on top because it already has a positive exponent. We have no need to change it. So just remember this little rule. When you cross the line, you can change the sign of the exponent.